At the beginning of the 17th century, Europe was teeming with ideas, conflicts, and discoveries. Astronomy, natural philosophy, and mathematics were beginning to reorganize, paving the way for one of humanity's greatest intellectual leaps. And in this turbulent setting was born the boy who would change everything, Isaac Newton. Isaac Newton was born prematurely on January 4, 1643, in Woolsthorpe, a rural village in England. He was so small that many thought he would die. His mother, Hannah, was left alone after her husband's death, weeks before his birth. Newton's childhood was marked by loneliness. When he was only 3 years old, his mother remarried and left him in the care of his grandparents. This deep separation shaped the introspective character of young Isaac, who sought refuge in objects, mechanisms, and long hours of observation. Still a child, he built miniature windmills, water-drop-powered clocks, and clever lanterns. While other children ran through the fields, Newton sought to understand how the world worked. At the school in Grantham, Newton was not popular. He was bullied, and after a fight with a stronger boy, something awakened in him, a fierce desire for intellectual achievement. He began studying compulsively. Soon, he surpassed all his classmates. In 1661, he entered Trinity College at the University of Cambridge. There he found a vibrant environment filled with debates about astronomy, natural philosophy, and mathematics. But Cambridge still taught much of medieval thought. Newton wanted more. He delved into the works of Galileo, Descartes, Kepler, and other giants of scientific thought. He absorbed everything with an almost obsessive intensity. Each book read was an open door to another question. In 1665, the bubonic plague hit England. Cambridge closed. Newton, then 22 years old, returned to Woolsthorpe. And it was during these 2 years of isolation that he experienced the most productive period in the history of science. It was there that he began to formulate the calculation, the theory of light and colors, and the fundamental principles of gravitation. Of course, the story of the apple is highly romanticized, but something similar happened. Newton observed an apple fall and wondered why all objects always fall toward the ground. The question led him to an extraordinary reasoning. If the apple falls due to gravity, does the moon also stay in orbit because of the same force? The central idea of universal gravitation was born. The same force that pulls the apple to the ground keeps celestial bodies in their trajectories. Newton also conducted experiments with light. When passing white light through a prism, he noticed that it split into distinct colors. This contradicted the old idea that white light was pure. For Newton, it was composed of all the colors that we saw separate. Dissatisfied with the optical aberrations of refracting telescopes, Newton created the first functional reflecting telescope, using mirrors instead of glass lenses. This revolutionized astronomy. Upon returning to Cambridge after the end of the plague, Newton was no longer just a student. He was a fully developed genius, with ideas that surpassed everything the Academy knew. In 1669, he became Lucasian Professor of Mathematics, one of the most prestigious positions at the university. But the official recognition was delayed. For years, Newton worked silently on his discoveries. He avoided publishing his studies for fear of criticism and heated debates. One of the major conflicts arose with Robert Hooke, an influential member of the Royal Society. Hooke believed he had contributed to the theory of gravitation, which caused intense tension between the two. Newton was sensitive to criticism, and the dispute drove them apart. The Great Fire of London, which devastated the city in 1666, reignited discussions about architecture, physics, and reconstruction. But Newton remained focused on his mathematics and his laws. The turning point occurred in 1684, when Edmund Halley, yes, the same as the future Halley's Comet, visited Newton and asked a simple question. What shape would the orbit of a planet attracted by the sun take if the force was inversely proportional to the square of the distance? Newton responded that the orbit would be an ellipse. Halley was perplexed. No one had ever demonstrated this before, and he asked Newton to present his calculations. Thus was born the monumental work, Philosophiae Naturalis Principia Mathematica, published in 1687. Halley financed the printing. Newton completely revolutionized scientific thought. Principia, he formulated the three laws of motion. First, a body remains at rest or in uniform, straight-line motion unless acted upon by an external force. Second, force equals mass times acceleration. Third, for every action, there is an equal and opposite reaction. Universal gravitation explained not only the fall of objects on Earth, but also the movement of planets, moons, tides, and even the shape of the Earth. The impact was devastating. Science would never be the same again. Newton had provided a mathematical framework to understand the cosmos. Already mature, Newton assumed important positions. In 1696, he became the warden of the Royal Mint, and later its director. He fought counterfeiters with a firm hand and reorganized the English monetary system. His reports were accurate, and his method for identifying fraud was unbeatable. Newton transformed the administrative role into a scientific mission. In 1703, he became president of the Royal Society. He held the position until his death. In the eyes of the public, Newton was the greatest living scientist. Your life was not free from disputes. The bitterest was with Gottfried Leibniz, over who had invented calculus. Today we know that both arrived at calculus independently, but at the time the quarrel became a national conflict. Newton, influential and proud, used his position to defend his priority. Despite his extreme rationality, Newton also delved into areas considered mystical, such as alchemy and biblical interpretations. He obsessively studied the nature of matter, seeking a hidden explanation. Your work on light and colors paved the way for modern optics. Your theories influenced generations of physicists. In the last years of his life, Newton was a revered figure. He lived comfortably, admired throughout Europe. He worked until the end. Isaac Newton died on March 20, 1727, at the age of 84, a remarkable feat for the time. He was buried at Westminster Abbey, an honor reserved for kings, poets, and national heroes. On his tomb, words were engraved that echo to this day. Nature and the laws of nature were hidden in the night. God said, "Let Newton be," and there was light. And so from a small English village was born the man who revealed to the world the language of nature. Newton showed us that the universe is not chaos, but rather mathematically structured order. His legacy remains alive in every satellite launched, in every equation studied, in every scientific question answered. The story of Isaac Newton is not just the story of a genius. It is proof that human curiosity can cross centuries and illuminate the shadows of the unknown. If this video brought you reflection, new learnings, or inspiration, leave a like, follow the channel for more discoveries. Thank you for watching, and see you next time.